Today, I want to share with you something incredibly powerful and immediately actionable for people over the age of 60. We often hear that muscle loss or sarcopenia is an unavoidable part of aging, but that's not entirely true. In fact, specific choices we make, especially around nutrition, can dramatically shift the way our muscles function, how strong our legs feel, and even how independent we remain as we age. What's fascinating is that the timing and composition of a single meal can set off biological cascades, molecular switches that directly combat muscle decline. And there's a particular type of breakfast backed by clinical data that doesn't just slow sarcopenia, it can reverse its trajectory and measurably boost leg strength in as little as 24 hours. So let's dive into the mechanisms, the practical applications, and most importantly, what you can do tomorrow morning to change the course of your physical health. When we talk about sarcopenia, we are really talking about one of the most significant biological challenges of aging, and it is often underestimated until it becomes visible in the form of weakness, instability, or the gradual loss of independence. Sarcopenia is not simply about losing muscle mass. It is fundamentally about the body's reduced ability to rebuild and maintain skeletal muscle tissue. This decline is driven by multiple mechanisms, including hormonal shifts, reduced physical activity, diminished neural drive to muscles, and importantly, impaired nutrient signaling. At the molecular level, muscles become less sensitive to the anabolic signals from food, especially protein, and less able to turn those signals into new muscle proteins. This is sometimes called anabolic resistance, and it is one of the major reasons why people over 60 often struggle to maintain strength, even when their diets appear to contain enough calories. This is where the concept of a protein-rich breakfast comes into play. For decades, the cultural norm has been to eat light or carbohydrate-dominant foods in the morning: toast, cereal, juice, pastries. While these foods may provide quick energy, they do little to trigger the processes that protect muscle. Protein, on the other hand, is the only macronutrient capable of directly activating muscle protein synthesis, the cellular process by which new muscle fibers are repaired and built. When you consume high-quality protein in sufficient amounts, particularly those rich in the amino acid leucine, you activate a molecular pathway known as mTRC1, which acts like a switch telling the body to begin building new muscle tissue. Without activating this switch, muscles continue to break down at a rate that is faster than they can rebuild, and over time that imbalance is what drives sarcopenia. Now, why breakfast? The timing here is critical. After a night of fasting, your body is in a catabolic state, meaning muscle breakdown has been occurring to some degree as your body mobilizes amino acids for repair and metabolic processes. By the time you wake up, your muscles are primed to respond to nutrients, but they require a strong enough signal to do so. Eating a protein-rich breakfast first thing in the day provides that signal at the most strategic time, essentially stopping the overnight breakdown process and flipping the body into an anabolic state. This matters especially for older adults because their muscles require a larger and more concentrated dose of protein to achieve the same response that a younger person's muscles would achieve with less. Research consistently shows that older adults may need upwards of 30 to 40 grams of high-quality protein in a single sitting to maximize muscle protein synthesis, compared to 20 grams for a younger adult. The importance of this morning dose of protein becomes clearer when we think about distribution across the day. Most people tend to eat very little protein in the morning, moderate amounts at lunch, and the majority of their daily protein intake at dinner. This uneven distribution leaves muscles understimulated for most of the day, and the body cannot make up for it by simply eating more protein at night. Muscles respond best to pulses of protein intake that reach a certain threshold. Therefore, if breakfast is protein poor, the body essentially loses an entire opportunity to trigger muscle building, and that's a third of the day lost in terms of stimulating muscle repair. Over weeks, months, and years, this pattern compounds and accelerates sarcopenia. Another layer to this is the role of leucine, an essential amino acid found in high concentrations in animal proteins like eggs, dairy, poultry, and fish, as well as in some plant sources such as soy. Leucine acts almost like a key in the ignition of muscle protein synthesis. Without enough leucine, even if you consume protein, the anabolic switch may not be fully activated. This is why the quality of protein matters, not just the quantity. A protein-rich breakfast that includes sources high in leucine ensures that the mTRC1 pathway is activated to its fullest, and this maximizes the body's ability to halt muscle breakdown and initiate repair. This effect is not merely theoretical. Clinical studies have shown that older adults who consume higher protein breakfasts demonstrate greater nitrogen balance, improved muscle mass over time, and even acute improvements in measures of strength and mobility compared to those who consume carbohydrate-heavy breakfasts. What is particularly striking is that even within 24 hours of making this shift, markers of muscle protein synthesis can be observed, meaning the body is responding rapidly to this nutritional intervention. It's not something that takes weeks to begin working. The benefits start the very first day the behavior is implemented. When we zoom out, the broader implications become clear. Sarcopenia is strongly linked not only to frailty, but also to increased risk of falls, fractures, loss of metabolic health, and decreased immune function. Muscle is not just a tissue for movement, it's a metabolic organ. By maintaining muscle mass, you preserve glucose regulation, reduce systemic inflammation, and maintain resilience in the face of illness. A protein-rich breakfast is not just about building bigger muscles, it is about preserving the systems that sustain independence and vitality. It is also important to recognize that pairing this protein intake with resistance exercise, even something as simple as bodyweight squats, light weights, or resistance bands, further amplifies the effect. Exercise sensitizes muscle tissue to the anabolic signal from protein, meaning that together they produce a much stronger response than either would alone. But even in the absence of exercise, for individuals who may be limited in mobility, simply adjusting breakfast composition can provide a meaningful benefit. This is why it is such a powerful intervention. It is accessible, it requires no prescriptions, and it can be implemented immediately without cost beyond choosing different foods. On a neurobiological level, there is also evidence that a protein-rich breakfast influences neurotransmitter systems, stabilizes blood sugar, and promotes sustained energy and focus throughout the morning. These effects, while secondary to the goal of halting sarcopenia, provide an added incentive for compliance. Many older adults notice that when they switch to a protein-rich breakfast, they feel sharper, less fatigued, and less prone to the mid-morning energy crash that comes with a carbohydrate-heavy meal. This creates a positive feedback loop. When a change makes you feel better quickly, you are more likely to stick with it. The point here is that this single, deliberate choice at the beginning of the day exerts disproportionate influence on the trajectory of aging. By choosing to start the day with a protein-rich breakfast, you are not only halting sarcopenia at a mechanistic level, but you are also setting the tone for nutrient signaling, energy balance, and metabolic resilience across the next 24 hours. Leucine is one of the 9 essential amino acids, meaning the body cannot produce it internally, and it must be obtained through diet. Among all the amino acids, leucine has the most potent role in initiating muscle protein synthesis, the biological process that allows muscles to repair and grow after being stressed by activity or simply undergoing normal wear. This is particularly relevant in the context of aging, where muscles lose their sensitivity to protein intake. This phenomenon, called anabolic resistance, creates a barrier that makes it harder for older adults to maintain strength and function, even if they consume what looks like a sufficient amount of protein on paper. Leucine is the amino acid most capable of overcoming that barrier because it acts as a direct activator of the MUNTORC1 signaling pathway, the molecular switch responsible for turning on muscle building. Without enough leucine, the signaling threshold is not reached, and the muscle remains in a net catabolic state, continuing to break down tissue. With sufficient leucine, however, the anabolic machinery turns on and the body begins synthesizing new muscle proteins, halting the progression of sarcopenia. This is not just a long-term theoretical benefit. Leucine has rapid effects that can be measured within hours of ingestion. Studies in older adults show that when they consume a leucine-rich meal or supplement, markers of muscle protein synthesis rise significantly, often within 3 to 4 hours. Because the muscles of the legs represent the largest muscle group in the body and are constantly involved in standing, walking, and stabilizing posture, they are especially responsive to these signals. This is why the effects of leucine intake can often be observed quickly in measures of leg strength and function. Clinical trials have demonstrated that individuals who consumed higher leucine meals or drinks were able to generate greater force in leg extension exercises, walk faster, and even rise from chairs more efficiently within a short window of time compared to those who consumed isocaloric meals with lower leucine content. The key difference is not calories or total protein, but the presence of sufficient leucine to activate the anabolic switch. Beyond leucine, the other essential amino acids also play a critical role. While leucine is the initiator, the actual construction of new muscle tissue requires the full complement of essential amino acids. Think of leucine as the foreman who starts the building process, but the other amino acids are the workers and materials required to complete the structure. If leucine is present but the other essential amino acids are absent or deficient, the anabolic process stalls. This is why whole protein sources or carefully formulated blends are superior to leucine alone. Foods such as eggs, dairy, lean meat, soy, and legumes provide both leucine and the other essential amino acids in balanced ratios, ensuring that the muscle building process can proceed to completion once triggered. The rapid effect of leucine and essential amino acids on leg strength is further enhanced by the way they interact with exercise. When resistance exercise is performed, even at relatively low intensities, muscle tissue becomes more sensitive to amino acid uptake. This heightened sensitivity means that when leucine-rich proteins are consumed after exercise, the resulting muscle protein synthesis is amplified far beyond what would occur with nutrition alone. This synergy is particularly important for older adults because their baseline anabolic resistance makes it harder to achieve significant gains with diet or exercise alone. Together, however, the two interventions create an amplified signal strong enough to overcome the biological inertia of sarcopenia. In practical terms, this means that something as simple as a leucine-rich protein drink after a walk or light resistance band workout can rapidly improve leg function in measurable ways. The reason leg strength is such a critical marker is that it correlates directly with independence and quality of life in older adults. Weakness in the quadriceps and other leg muscles is strongly associated with difficulty rising from a chair, increased fall risk, and slower walking speed, all of which are predictive of disability and even mortality. By targeting the very mechanism that drives improvements in leg strength, leucine and essential amino acids are not just helping build muscle, they are extending functional capacity and potentially delaying the transition into frailty. This is why many gerontology researchers emphasize nutritional strategies that are not just about body composition, but about the preservation of mobility. Another fascinating aspect of leucine's action is its role in the nervous system. Emerging evidence suggests that leucine may influence the neuromuscular junction, the point at which nerves communicate with muscle fibers to generate movement. With age, these junctions can deteriorate, leading to impaired communication between the brain and the muscles. By stimulating protein synthesis and supporting structural repair, leucine may indirectly enhance the efficiency of these neuromuscular connections. This translates into not only stronger muscles, but also more coordinated activation, which is critical for balance and functional leg strength. When considering practical applications, it becomes clear that the dose of leucine is a decisive factor. Research suggests that older adults need approximately 2.5 to 3 grams of leucine in a single meal to maximally stimulate muscle protein synthesis. To put that in perspective, this equates to around 30 to 40 grams of high-quality protein from sources such as whey, chicken breast, or soy. Whey protein is often highlighted as particularly effective because it is rapidly digested, high in leucine, and provides all essential amino acids in optimal ratios. By designing meals or supplements that meet this leucine threshold, older adults can ensure that each eating occasion is an anabolic event rather than a missed opportunity. There is also evidence that the timing of leucine intake matters. Consuming leucine-rich protein earlier in the day may help set the tone for muscle metabolism across the waking hours, while distributing intake evenly across 3 meals ensures multiple pulses of muscle protein synthesis. Skipping leucine-rich meals or concentrating protein only at dinner results in long stretches of the day when muscles remain unstimulated, accelerating sarcopenia. By contrast, regular and sufficient leucine intake throughout the day provides repeated anabolic signals that sustain muscle maintenance and growth. The acute improvements in leg strength and function observed with leucine and essential amino acids are not just laboratory findings, they translate into meaningful real-world benefits. Older adults who integrate these nutrients into their diets report greater ease climbing stairs, more stability when standing, and reduced fatigue during walking. These changes, even when modest, can make the difference between dependence and independence, between avoiding a fall and suffering a fracture. In a population where declines in mobility often happen gradually and are accepted as inevitable, the rapid and tangible impact of leucine provides a powerful counter-narrative that strength and function can be regained at any age with the right biological triggers. Leucine and essential amino acids also play a role in muscle recovery from illness or injury, both of which are times when muscle loss can accelerate dramatically. Hospitalization, bed rest, or even a period of reduced activity can cause older adults to lose significant amounts of muscle in a matter of days. By providing leucine-rich nutrition during these periods, the loss can be minimized and recovery of leg strength accelerated. This is not a marginal benefit, but a clinically meaningful intervention that can determine whether an individual returns to full function or remains in a weakened state permanently. At the biochemical level, what is striking is the elegance of the system. The body has evolved to respond to specific amino acids as signals of nutrient availability, and leucine is the most powerful of those signals. It is not just about providing raw material, it is about instructing the body to use that material in the service of growth and repair. For older adults, where the default trajectory is one of decline, the ability to harness the signaling pathway represents a profound opportunity. By ensuring adequate intake of leucine and the other essential amino acids, the cycle of breakdown can be interrupted and reversed, and the results manifest quickly in the muscles that matter most for daily life, the muscles of the legs. The timing of nutrient intake is a powerful yet often overlooked variable in human physiology, and when it comes to muscle maintenance and combating sarcopenia in older adults, the first meal of the day carries disproportionate influence. After an overnight fast, the body has been in a catabolic state for many hours. Energy reserves have been drawn upon, amino acids have been mobilized from muscle tissue, and glycogen stores in the liver have been reduced to maintain blood glucose stability. This period of fasting primes the body for a nutritional signal, and the nature of that signal determines whether the next phase of metabolism will favor muscle breakdown or muscle building. When the first meal is rich in protein, particularly with sufficient leucine and essential amino acids, it flips the switch toward muscle protein synthesis, setting off a cascade that protects and strengthens muscle tissue. When the first meal is carbohydrate dominant and protein poor, the signal is weak and the body continues in a catabolic trajectory that erodes muscle integrity. Older adults face the challenge of anabolic resistance, meaning that their muscles require a stronger nutritional trigger to initiate protein synthesis compared to younger individuals. This makes the timing of protein intake even more crucial. A protein-rich breakfast is not simply about hitting daily macronutrient targets. It is about delivering the right nutrient at the right time to overcome diminished sensitivity. Studies show that when older adults distribute protein evenly across meals, rather than concentrating it at dinner, they achieve higher total rates of muscle protein synthesis across the day. Breakfast, being the first opportunity, is essential in this distribution. If that opportunity is missed, it is not possible to fully compensate by eating more protein later in the day because the muscle system responds best to periodic pulses of amino acid intake rather than a single large bolus. The connection between the first meal and mobility is direct and measurable. Leg muscles, which govern walking speed, balance, and stability, are highly dependent on repeated anabolic stimulation. When they receive amino acids early in the day, they are better able to repair the microdamage caused by normal activity and to prepare for the physical demands of movement throughout waking hours. This results in improved gait speed, reduced fatigue during walking, and greater ease in standing up from seated positions. These functional improvements are not abstract markers. They represent the very foundation of independence in older adulthood. A person who can rise from a chair without assistance, climb a staircase without stopping, and walk confidently is a person whose quality of life is preserved. The first meal plays a central role in enabling these capabilities because it determines whether the muscles are replenished or left in deficit during the most active portion of the day. The metabolic signaling triggered by the first meal also influences hormonal cascades that further affect muscle and mobility. For example, a protein-rich first meal leads to more stable blood glucose responses, avoiding sharp spikes and crashes that can cause energy fluctuations, dizziness, or impaired coordination. Stable glucose and insulin dynamics also support reduced inflammation and improved recovery, both of which are important for maintaining joint health and muscle function. In addition, protein ingestion stimulates the release of gut-derived hormones like GLP-1 and PYY, which contribute to satiety and metabolic balance, creating a more favorable environment for sustained physical activity. These hormonal effects compound with the direct impact of amino acids on muscle tissue, making the timing of protein intake a cornerstone of daily metabolic health. From a circadian biology perspective, the body's responsiveness to nutrients changes throughout the day. Morning and early daylight hours are associated with heightened insulin sensitivity, greater efficiency of nutrient partitioning, and improved muscle uptake of amino acids. This means that the same protein consumed in the morning may produce a stronger anabolic response than if it were consumed late at night. Aligning the first meal with these circadian patterns ensures that nutrients are used in the most efficient way to support muscle preservation. Ignoring this natural rhythm by delaying protein intake until later reduces the efficacy of the nutritional intervention and leaves muscles undersupported during the most active part of the day. The psychological and behavioral effects of the first meal are also important in shaping mobility outcomes. When breakfast is protein-rich, older adults often report greater sustained energy, reduced cravings for sugary snacks, and improved mental clarity. These subjective changes translate into a higher likelihood of engaging in physical activity, whether structured exercise or simply more spontaneous movement throughout the day. Increased activity further sensitizes muscles to amino acid uptake, creating a positive feedback loop in which the timing of protein intake and movement reinforce each other. By contrast, a carbohydrate-heavy breakfast that causes energy dips can reduce motivation to move, leading to more sedentary behavior, which accelerates sarcopenia. Leg strength, in particular, benefits from this alignment of nutrient timing and activity. The legs carry the body against gravity, and their muscles are heavily involved in locomotion and balance. They are also the muscles most vulnerable to disuse atrophy in periods of inactivity. Providing amino acids early in the day ensures that when these muscles are called upon, whether for walking, standing, or exercise, they are in an anabolic environment that supports adaptation and recovery. Over time, this repeated early stimulation translates into measurable gains in muscle mass and function, as documented in intervention studies where older adults consuming protein-rich breakfast demonstrated faster walking speeds and stronger grip strength compared to control groups. Timing the first meal also has implications for mitochondrial function within muscle cells. Amino acids, particularly leucine, not only stimulate protein synthesis but also promote mitochondrial biogenesis, the process by which new mitochondria are created. Mitochondria are the energy-producing structures of cells, and their efficiency determines how much endurance and strength muscles can sustain. By providing amino acids early in the day, the body supports both the structural repair of muscle fibers and the energetic machinery that powers them. This dual benefit enhances endurance and reduces fatigue during activities that require leg strength, such as walking or climbing stairs. The choice to prioritize protein in the first meal also interacts with overall dietary patterns. Many older adults consume insufficient protein across the day, and the easiest way to correct this is to front-load intake at breakfast. By establishing protein as the anchor of the first meal, individuals create a foundation that makes it easier to hit total daily targets. This is critical because the cumulative effect of protein intake across multiple meals is what ultimately halts sarcopenia. Each pulse of protein synthesis contributes to the preservation of lean mass, and missing the first opportunity diminishes the total anabolic response. In the broader context of healthy aging, mobility is one of the strongest predictors of longevity and quality of life. Mobility depends on muscle strength, and muscle strength depends on both activity and nutrition. The first meal of the day is the junction where these systems meet, and its timing dictates how effectively muscles respond to the stresses and opportunities of the day ahead. By delivering protein early, the body is equipped to sustain movement, resist the decline of sarcopenia, and maintain the physical independence that defines successful aging.